Lesson, I want to talk about two other types. So first one being how do we multiply two complex numbers, and then the second one being how do we divide two complex numbers. We already learned how to add complex numbers and how to subtract complex numbers. So before we multiply or divide complex numbers, one of the very important identities that we have to keep in mind or kind of have to use here is the fact that I square equals to -1. Again, this is not a magical identity. It is something which comes from the fact that we identify or we set radical -1 equal to I as an imaginary unit. If you square both these sides, you get I square, and if you square this radical -1, the square and the radical crosses out because they are opposites, and you have I square equals to -1. So keeping that in mind, let us first look at an example. How do we multiply two complex numbers? So I'll call that example 3. So let's say we have two complex numbers, 2 plus 4i, and we want to multiply that with 3 minus 5i. So we can clearly see that we are multiplying two complex numbers. There's a difference between multiplying and adding two complex numbers. In the previous video and in the previous examples, we had two complex numbers, but there was a plus in between them. That means we had to add them. But here there's no plus. There's actually nothing in between them, but we already know when you have these two parentheses next to each other, there's always that invisible multiplication, which we do not really like to draw or write, but it has to be understood that there's a multiplication here. So we are trying to multiply these two complex numbers. So in order to multiply these two complex numbers, one of the best methods that I like to use is the method of distribution. So I start with 2 and I draw these arrows which tells me that which two numbers or two quantities I have to multiply. So I start with drawing this arrow from 2 to the first number here, and I also start by drawing another arrow from 2 to the next number. So that tells me that I have to start with 2 and distribute or multiply this 2 with both of these quantities, but at the same time, once I do that, I also have to make sure that I'm distributing each and every piece of the complex number. So then the next quantity is this positive 4i. We also have to distribute or multiply that with the other quantities, so I also like to draw those arrows as well. Starting from this 2 right here, so this equals to 2 times 3, which is 6. Then we have 2 times -5i, which is -10i. Please be careful with the negatives because 2 times -5 is -10. Then moving on, that takes care of the 2. Now moving on to the second quantity 4i. Positive 4i times 3 is positive 12i, and then we have our final term, which is the most important term here. Positive 4 times -5 is -20, but then we also have I times I, and I times I is going to work like you have x times x, which is x square. Similarly, I times I is going to be I square. Okay, so once you have it in simplified after distribution or multiplying, some of you like to use the FOIL method. I'm fine with using the FOIL method, but this actually helps me. It is easier to do the distribution because then I have these like terms together in the middle. So I can move on and simplify this. Well, 6, I can leave it like that, but I can see here both these terms are imaginary units, so I can combine them. -10 plus 12 is plus 2i. And then I have a -20 I square, but we already know that I square is equal to -1. So whenever we have an I square, when we multiply, divide, or in any other situations, we always have to replace that I square with a -1. So I'm carefully going to replace that I square with -1, which means I'm going to put that in parentheses. So if I put that in parentheses, moving on, this equals to 6 plus 2i. We all should actually write all our steps clearly, that avoids us making any mistakes. That's why I'm writing out all the steps, and I always like to do that. Then you have -20 times -1. So negative times negative is positive, so it will be a positive 20. Okay, so we already have simplified the imaginary units, imaginary pieces, and now we have two real pieces which we can combine together. So 6 plus 20 is 26, and then I have a 2i with it. So this is already in the simplified form. How do we know this is a simplified form? The best way to figure out that this is a simplified form is to see that we can clearly figure out or identify the real and the imaginary part. So the real part for this example would be 26, and the imaginary would be the quantity or the number which is in front of the I, which is a positive 2. So we have both real and imaginary parts of this complex number, which is simplified by multiplying these two complex numbers. So please look carefully at all the steps. You distribute, then you combine like terms, replace I square with -1, again combine the real parts, and there you have the product of two complex numbers. So that was the product. Now let's move on to our final example, example 4, where we want to actually look at a division example. Let's say we have 2 plus 3i, one of the complex numbers, and we want to divide this with another complex number, let's say 3 plus 2i. So if we are trying to divide a complex number by another complex number, remember our goal is to simplify this, and also we want to identify the real and imaginary parts. So if you look at this complex number here, you have the real and imaginary part for the numerator, which is very easy to see, and you also have a real and imaginary part for the denominator. But that's not what we want. We want to simplify this, and we want to have just a one real and one imaginary part. So how are we going to be able to do that? So in order to actually simplify this, we have to use an additional piece of information, which is called the conjugate, or the complex conjugate of a complex number. Now, what is the complex conjugate? Let us quickly define the complex conjugate. So complex conjugate, if you have a complex number, and let us say I'm going to work with this one. So let's say 3 plus 2i. How do we plot this 3 plus 2i? So we always think of this complex number as an ordered pair. So as an ordered pair, this can be thought of as a point 3 and 2, right? This is the 3 from the real part, and 2 is the imaginary part. And to plot the complex number, we still have a similar xy type of a coordinate plane, but we do not like to think of horizontal axis as an x-axis. Instead, we like to think of that as a real axis. And then the vertical axis obviously will be thought of as an imaginary axis. So we have real and imaginary axis. This is my real part, and this is my imaginary part. So if I have to plot it, it's 3 units on the right and 2 units up. So this is my, approximately this is the complex number. This is the plot for this complex number right here. Now, how do we define a complex conjugate? A complex conjugate is simply a reflection of this complex number across the real axis. So if we have to draw the reflection of this point across the real axis, it's going to be somewhere up here. And what are the coordinates going to be? So x coordinate, sorry, the real coordinate is still going to be 3. But on the other hand, the imaginary coordinate is going to change from positive 2 now to a negative 2. And this point, written as a complex number, so this is the conjugate, and conjugate is represented by an horizontal line on top of z. We know z represents a complex number, and horizontal line like this over z represents the complex conjugate. So the complex conjugate of this complex number equals to it is reflection across the real axis. So if I have to now, this is the reflection. If I have to transform this coordinate pair into a complex number, the real part is 3, the imaginary part is negative 2, so it's going to look like 3 minus 2i. Okay, so complex conjugate is something which is very useful when we are trying to divide two complex numbers and when we are trying to find the real and imaginary part. What is a complex conjugate? It is simply the reflection of a complex number across the real axis. So if this is the complex number right here, the reflection is going to be right here. Similarly, we could have a different complex number. For example, I have a complex number right here. Then the reflection would be somewhere up here, and we have a different complex conjugate. But if you look carefully, the complex conjugate is always going to be similar, very much similar to what the original complex number is, except for you have to change the sign in front of the I. So in this case, you had a positive 2 in front of the I, the complex conjugate has a negative 2 in front of the I. So how are we going to use that complex conjugate? To simplify this, what we do is, and this is a technique that you are seeing probably for the first time, but you have to try to understand and remember the technique and see why are we using this technique. So once you go through and you see all the steps, you will see the point of using this technique. So what do we do with this complex conjugate? First, you find out the complex conjugate of the denominator. We're only interested in the complex conjugate of the denominator, which is already here, 3 minus 2i. Then you multiply both the numerator and denominator by that complex conjugate. So I'm going to multiply this with 3 minus 2i and 3 minus 2i. So that's a very useful thing here, because that's going to make it more simpler, and that's going to simplify this. That's going to help us to find the real and the imaginary part. Once you multiply upstairs and downstairs by the complex conjugate, then you simply have to do a multiplication problem, but you have to do it twice. You are multiplying the numerator and you are then multiplying the denominator, and then you got to still probably simplify. But the reason why we are multiplying, one of the reasons why we are multiplying this upstairs and downstairs is that if we multiply this, we are multiplying the same quantity upstairs and downstairs. That does not change the original ratio. That does not change the original division problem. So we are allowed to multiply the same quantity with the numerator as well as the denominator. The other reason will be evident once we simplify, because we are trying to remember, we are trying to find the real and the imaginary part. So let's move on and quickly try to distribute or try to multiply these two complex numbers. So again, we're going to do the same thing. We are going to draw the arrows, and then we're going to do the other arrows, and we're going to multiply. 2 times 3 is 6. 2 times negative 2 is negative 4i. Then I have 3 plus 3 and positive 3 here, which is 9i. And finally, I have positive 3, negative 2, negative 6. Please do not forget the I times I, which is I square. So we are almost done with the numerator. Then we got to do the same thing for the denominator. 3 times 3 is 9. Then 3 times negative 2, negative 6i. Then I have 2 times 3, positive 6i. And then I have positive 2, negative 2, which is negative 4, and I square. So what's going to happen in the denominator, which you may be already able to see, this positive 6 and negative 6, they will cross out. And it's always going to be the case if we have multiplied the correct conjugate upstairs and downstairs. It's always going to be the case that the middle two terms, like the middle two imaginary terms, will be crossed out. Okay, so let's move on and simplify here. So we have 6. Negative 4 and positive 9 can be simplified because they are imaginary pieces, so it's plus 5i. And then I square has to be again replaced with negative 1. So if I replace this I square with negative 1, that negative 1 times negative 6 is going to be positive 6. So we can kind of skip that step. Downstairs we have 9, but I square will be replaced with negative 1, making it positive 4. 9 plus 4, which is 13, right? So I hope you can see that now why we are trying to multiply both upstairs and downstairs by the conjugate. One of the reasons was that we want to get a real number, a pure real number downstairs without any i's. So when we multiply this complex number by its conjugate, what happens? We get a real number as our final answer. So this equals to 6 plus 6 is 12 plus 5i divided by 13. We are almost done, except for the fact that this 13 divides the 12 as well as the other part, 5i. So this is going to be like 12 over 13 plus 5i over 13. So this right here is our final simplified form. When we divide this complex number by another complex number, we had to find the complex conjugate of the denominator, multiply upstairs, downstairs, simplify. Finally, we have this. And what is good about this one is we can now clearly see that the real part, because the real and imaginary parts are completely isolated. The real part is 12 over 13 and the imaginary part is 5 over 13, and that is what we wanted to accomplish. We wanted to simplify, and the most important part for us was to identify the real and imaginary parts, which are right here. So I can understand that the division has more steps, is more rigorous than any of the other procedures, multiplication or addition and subtraction. but it requires us to be careful with multiplying the complex conjugate, understanding what a complex conjugate is, and then simplifying, combining like terms, and finally dividing both these terms separately by the denominator, and finally we have the real and imaginary. So this is the 4 types: addition, subtraction, multiplication, and division. In the next video I'll be talking about how do we find the absolute values, and how do we simplify other different types of complex numbers, and how do we solve equations which have complex solutions.